Hey guys, yeah, so we're back. Um, in this session, I'm basically just going to go over the NAO Humanoid, the choreograph software for controlling NAO, and VBot simulator. So let's start off with NAO. It's visible, right? Okay, like I said, these session agendas first, humanoid robotics, just an introduction, and then deep dive into NAO, real world applications and impact of NAO. So there have been a few success stories of NAO that I'll elaborate on later, and then we can have some kind of QA. If you guys want to anything. So just an introduction. A lot of you might not know what NAO is, right? So NAO is a humanoid robot that was made by SoftBank Robotics, formerly known as Aldebaran so it's a 58 centimeter tall programmable robot. It has 25 degrees of freedom. The thing is, it's hip joint, right? It has two motors there, but they operate synchronously. So instead of 26, it's actually just 25 degrees of freedom. So yesterday, Jaikan sir would have explained what exactly degrees of freedom is. Um, Other than that, I guess there are a lot of research areas. One is HRI, which is the main area, human robot interaction. So since it has two cameras, four microphones, a whole bunch of joints for gesticulation, etc., you can use it for effective HRI studies. I'll show you some stuff later on that. So initially, now was envisioned or conceptualized around 2006, and it entered its first global competition. That is, I think it was Robocup in 2008. Um, right now, after that, it has become such a legend at Robocup that they have a dedicated soft football league for now, where you'll have teams of 11 now robots competing on a soccer field. So that's how much it's grown actually. You can search on YouTube, you'll find videos. It's really cool to watch. Um, and there have been a few other refinements. It is now 4, I believe. And the latest version, there is now a V6. It has AI integration and stuff. It has onboard NPUs, so it can handle lightweight AI models and everything. Right now, we have now 4, which is capable of everything except AI deployment. Like I said, the applications involve mainly HRI because that's the kind of that's kind of its strength. Since it's a humanoid, you can get it to interact with other people and record the results of those studies. For example, or ASD, autism spectrum disorder. So they used now in a study in Europe. It was called the Dream Project, I believe. So where they tried to give assistive therapy for autistic students using now, and they saw very promising results. Apart from this advanced robotics research, for example, gripping, throwing, etc. Since it has those arms with a whole lot of gearing and intricate joint mobility control, you can actually use it to build RL models for specific robotic research areas. Um, a little bit information on steps. This is right in the idea. Like I said, 25 viewers, very fluid movement, which I'll show off in just a minute. Vision, there is two HD cameras for normal stuff like object recognition. It tracks your face. So if I were to move that side now, I will turn. Like right now, it's in sleep mode. So if I were to put it in autonomous life mode, where it actually scans for objects, it will turn according to wherever the ROI is. Um, it has four directional microphones, two on each side, so that it can create a sort of parallax vector to identify where the object is. So I'm creating some noise and speaking. So if I go that side, it will turn along with me because it understands that noise is coming from there using those directional microphones. It has tactile sensors. So if you see I just mentioned the launch of Soccer League at RoboCup. So it has to use those tactile sensors to find out how much force to apply to kick. These are like whether the kick has already occurred. All of these events have to be recorded, right? So this is very useful for that. And we have like IMU. And IMU is basically just a gyroscope and an accelerometer together. It has a three-axis accelerometer and three-axis gyroscope. Now, what the accelerometer does is it gives readings like change in X, Y, and Z coordinates at any given moment. So right now I'm static. If I have an IMU inside me, when I move like this, let's say this is the y-axis, it will say that there's this much change in y-axis. Like this, you'll keep getting hundreds of samples per second. That's the job of an IMU. And why that is useful is using that you will create a closed loop control system for the robot, where based on its real time sensor input, it sort of fine tunes its motion. Like I said, the success stories of now, the two main things are pilot studies and guided exercise demos for the elderly. So basically, like physiotherapy. So it's very easy to use a robot to visualize, intricate movements. So if you have to guide a class on physical therapy, it becomes, a great choice. And the second thing is the DREAM project in Europe, where it assisted uh, children with ASD in certain learning tasks. Yeah. Yeah, they'll be going into a deep dive actually. It'll be very interesting. Yeah, yeah. They will be giving like an in-depth review of the results of that study, basically. I mean, yesterday's session, those who attended, you will get understand what they do. Like they'll give you a proper flow of exactly what they did so that you can get a better understanding. So like I said, huge number of joints. So just in the head, there is pitch and yaw. I mean, no roll obviously, but there is pitch and yaw, where pitch is up down, yaw is left right, right? So like this, these names are important. I think it's hard to see in this name. Arch shoulder pitch, arch shoulder roll, right? Shoulders pitch value. Okay. So each of these joints has have these identifiers for each type of motion. So if the shoulder has pitch roll and yaw, then it will be arch shoulder roll, or arch shoulder pitch, and arch shoulder yaw. Now these parameters are what you're going to be naming in the programming, right? So in choreograph, you will use these exact identifiers to give numerical values as to how much pitch, how much roll, how much yaw. Okay, and this goes for every joint. Um, Okay, so there are three widely used development approaches or development interfaces. One is choreograph, which I'll be showing soon. It's a graphical drag and drop environment. It's like graphical programming, basically. Some of you might have done it in school. I mean, not for choreograph, but graphical programming, where you will add like boxes and connect those boxes in a sequence. So if I want the robot to stand up, like this is home position where you are seeing it right now. If I wanted to stand up, walk, say, for 2 seconds, and then wave. You will take the, stand up box, walk box, wave box, adjust the parameters to whatever you want. Like if it has to walk for 5 steps, you adjust it according to that. Like that, if you open the box and adjust it, you will be able to connect those boxes together and do that sequence of motion. It also supports certain advanced features like timelines and looping and recursion, but these are a little bit harder to get into unless you already have some knowledge in robot programming. Okay, so yeah, it can be like an educational tool if you wanted to, but it's also very, very powerful and you can build entire applications with it. And then there's the Python SDK. The Python SDK interfaces with the Naoki API. Naoki is the OS which runs on Nao, like on board. So you're going to use the Python API to act as an interface between Naoki and this, right? So there you have predefined functions which you can just call and give parameters, make it do actions. But it's a little bit more low level than choreograph. The C++ API is like just an alternative to Python. So if you're one of those people who want to use C++ instead of Python because you like pain, so you can use that. Uh, now the framework. So there's like sort of a layering of now, right? So you have the core services which are running on the core in now. Okay. This is like the system runtime and the services which are always up. On top of that, you have modules that is perception, vision, behavior, all of this. On top of that, you have the API layer, like I said, Python or C++ SDK. On top of that, you have the user applications. Okay, so user applications are what you build. So if you were to open Choreograph and build some, huge applications with hundreds of boxes, loops, recursion, whatever, that will be your application. Now, if I want now to teach a regular lesson to kindergarten children, I will create an application for that. Okay, so this is how everything is packaged and structured. Uh, there's the same thing, except like ROS integration, right? So, how many of you are familiar with ROS or at least heard of it? Okay, not many of you. Okay, fine. So, ROS is essentially like what to say? It's called robot operating system. It's not really, it's not really an OS. It runs on Linux and it allows you to containerize different what do you call it? For the lack of a better word, yeah, fine. Entities, but not just entities, even services you can have, right? So it'll allow you to containerize them and run them in real time. Now, why ROS is important is it provides some kind of common platform for development of everything in robotics. If I were to build my own custom robot, I can still use ROS. But here Navo is sitting as a proprietary hardware, right? ROS already has packages for Navo. You can just get them and use them. Since it's proprietary, we can't really fiddle around with its firmware, whatever, right? But if you were to develop custom things, then ROS is your go-to. Uh, and of course, there's Gazebo simulation. When there's ROS, there's Gazebo. So Gazebo runs in ROS or on ROS, and it just provides you a digital twin. So if you want now to do a backflip, you want to simulate it first, make sure it works, and then you're going to do it to the real robot. Okay, so remember I was talking about choreograph, right? Is this too fast or you guys okay? Okay. Until where did you guys follow? Should I roll back a little bit or after Ross? Okay. So fine. Ross is essentially it's a middleware. So you go to it runs on Linux and you can also run it on Windows using WSL, but then it's a headache because you have to map IPs between Windows and Linux. Yeah, all networking will have some kind of issues in WSL because WSL has its own things, right? But yeah, its own environment. Like config in Windows is done using the GUI directly, but then in Linux you'll have to go to the dash dot bash RC file and do it. Like this, there'll be several differences, and network ports in Windows are called COM3, COM4 or something. In Linux, it has a different name. Like this, you're gonna have to deal with lots of issues. So it's recommended to use Linux if you're going for robotics in general. Back to the point. So ROS is a middleware which runs purely in Linux, and it just provides you a platform. It provides common entities like nodes, services, topics, etc. I won't go too much into ROS because that's a whole thing. Like we'll have to have a workshop on ROS only. So it's out of the scope of this. It takes a lot of even I have to brush up before I say anything, right? Anyways, after that, are you guys cool? Do you need anything? Please ask questions. We get lost in between. Okay. Oh, choreograph. Uh, choreograph, like I said, it's now a visual programming environment. And I'll just show you the interface actually, why bother with this. So the main thing is choreograph, like when you open it, you want to see a digital twin of now. This thing is called the project panel. The project panel, I'll zoom into it later. It has different behaviors, predefined modules and boxes. This is your box editor or behavior editor. So basically, you will pull drag and drop boxes here, create connections. Suppose I wanted to walk at a different speed, I click on the box, open the code, change one small numerical value, and it works. Simple enough. I'll show you in real time also. Yes, it's purely built by Aldebaran for now. There is no loop here. It's just a simple sequence. It's just a sequence, but there are also loops. Like you have to get a looping box. And there is also a timeline editor. There's a little bit advanced topics which you will have to, there's a nuance to it. You will have to actually learn it. However, the basic thing is, let me just zoom in, hold on. Is it visible or we need to zoom in? Okay. It's a little bit better resolution, I guess. Okay, so connect to your now, which will be on the same network. I'm using Ethernet, you can use Wi-Fi. If you're using Wi-Fi, you click now, it speaks out its IP address. So the choreograph software is on that laptop. I'll show you like right after the presentation how to do all of that. Right? So, like I said, for example, let's say in modes. In modes, you have positive, negative, and neutral. In positive, for now, I mean, this supports NAO and Pepper actually. Pepper is also developed by same software robotics. So you choose NAO. In that, you choose whatever subject it will be according to that, right? So like this, they have hundreds of boxes already set up with adjustable parameters. So anything you want to do with NAO, you can definitely do with choreograph. There is no limitation as such. Okay? But if you're doing much more tinkering, you're having some kind of complex control or something for gripping, then you're going to go for ROS instead, or maybe the Python SDK. So the core modules you can generally, there's not a hard categorization by the way. Generally, you can classify them into motion, audio, and vision. Okay, like I'm just saying for your understanding, this is not a hard classification that exists on paper. Now, for example, in motion, you will have stand up, sit down, walk, where you can change the direction and speed. This arm and head movement, there are predefined poses. So you open the poses folder, in that there will be different subfolders. Then you open the pose you want. This is how it usually goes. You get the idea? Anyone has any issues until now? It contains STT and TTS modules. Yeah. This is the general flow. In choreograph, you just open that particular joints box. In that, it will open into one code file. There you can control the parameters alone. Like you don't need to disturb anything else. Just those parameters you can change. So if I want only these many degrees, I'll just enter 28 degrees. That's it. Anyway, so this is general workflow, right? We start a new project. You open choreograph, start a new project, add whatever boxes you want, connect those boxes, you configure the parameters like I said before, and test it. It's a very simple workflow. And so there where you can embed custom code within the boxes, where instead of just changing the parameters, you're changing the entire thing. There are conditional flows with FLs. Like I said, there are loops, there's recursion, there's timeline editor. All of these are a little bit more complex. You need to know robot programming. There is no other book. Um, and these are just examples. So if I wanna, just for example, make now wake up and say something, right? I just connect now using that connection icon, and then I add a wake up box, which you can find in that box library. And then I add a standard box, free box. In that, if I click it open, you will see a string that is editable. Okay. So in that code, you locate that string. I can change it to say hello, I'm Ashwin also. Yes, edit it and connect those things together. I'll show you how to connect this in a second. And you can run that. And the sequence will just work. For precise joint control, like I said, those identifiers that I showed you in the previous diagram, help to the role, help this job. Open and configure the actual degree values. That's it for the presentation. Now let's just move on to the demo. Really working hard right now. So it was just a pre-programmed sequence that I played. All I did is add boxes onto the parameters and they get added. It's an audio process music you use to play music like what is happening, right? So these motors do the working these are like the bigger models like that. When you look at this vertical cost imbalance, you have to minimize the imbalance and make every other motor feedback and communicate this or other something stabilize itself, right? So actually it's going to a lot of complex to make sure that many things that if you use this way, it's not a form of work. You can't get that happen. So this has to get some counter movement for that. So that's not a number of studies. This design is intricate enough that the cost of now that there is a level 68 lakhs within the minimum model. This is not great. So you can imagine how it works to making it control. So for any question, there has to be some kind of complex so that's just a second. Screen share. Request ಕೇಳ್ತಿದೆ requesting mention. Ah, so, guys, I hope my screen is visible now. I'm sorry about the misaligned pages. Yeah, okay. So you guys can see this is the Gangnam style code. Okay, whatever just happened now, it just took these six boxes to make that happen. That's the power of choreographs. It provides this highly abstracted GUI that just you can do things very quickly. All it has to do is turn off. I mean, the motor on off just activates all the motors, like it allows them to be activated, right? So after that, it stands up. Stand up is just a box. I don't have to configure how much time it has to give current to which motor and all. It just stands up, and then it plays the audio. And the composition is like a little bit intricate, like the dance. So if I click that open, you can see the code. Yeah. Again, I open Gangnam Style. It has its own thing. Go to post, dance, stand. If I open it, it will keep going on. So there are a lot of things that have been done for that dance motion alone. So let's just condense into one box. So if I open this, there are sub boxes, right? Let me just go back to root. After that, it has to. So this is the timeline editor. I opened the go to post box, which is a part of the Gangnam style thing. I opened it. You have a timeline editor. Here, according to the timeline, it changes its actions, right? So again, lot of things to cover. So this is kind of how it goes, application development using choreographs. Okay. Any questions? It's Q&A time. Okay. Let's say there are a few ongoing projects actually. First of all, we kind of regroup people, first teach them how to use now, and then we propose projects and then move on with them. One potential application could be, say, perhaps I want now to be a gym instructor. It can show the form of exercises perfectly. Like it's not going to, fail you in that aspect. So if I want to show people how to do an exact deadlift using a robot, I can just program that sequence so the form is perfect and it's easily understandable to the user, right? So let's say I'm just creating an intricate exercise companion with, since it has microphones and vision as well, I can ask it doubts in between and make it respond. So there's just no limit to scope, man. It has a lot of domains where it can be applied. Any questions, guys? No, everyone wants to see dance only. No, no questions at all. Okay. What's the time? 11:30. If I do you want to continue with auto? Oh, right. I can show reports. Hold on. Okay. So no questions in now. I'll move on to reports, the simulator. Okay. This is it, right? Okay. So now we'll be moving on to VBOT simulator. VBOT, just like VBOT, just like Gazebo, for example, it's just another robotic simulator, except it's a little bit more approachable. Um, Robots is one of the oldest robotics simulators out there. 1998 or something, the first version came out. It's a very old thing, but obviously it has been updated. There are new versions and everything. So let's start off here. So it's an open source 3D robot simulator. It's developed by Cyberbotics, and the key thing here is it has physics based simulation. So it's gonna follow proper real. I mean, it's got the fidelity between the physics in robots and real world physics is very high. That's what I'm trying to say. So it has its own application because of that. Let's say let's take the soccer game example. So you remember RoboCup, soccer softball league, right? So if I want to simulate a swarm of Navo robots playing football, that requires very high fidelity physics. It has to be, an accurate representation of real world physics, right? So for that, rewards is a great option. I think most people use rewards only for that actually. I'm sure there'll be a snippet of that inside. And of course, one of the key things is it has cross-platform compatibility. So it can be operated on Windows, Linux, Mac OS, and everything. You can just download an application online. It's not as hard to configure as Choreograph or ROS. I mean, the issue with Choreograph is if you guys are going to actually go out and try it, which I doubt you are, but if you are going to try it, you need Visual C++ 2013 for certain versions and 2017 for certain versions. For that, you're going to have to tinker a lot with the Windows OS, and it will stop you from installing on it. So get ready for some frustration, guys. Anyways, so the box is very easy to use, very accessible, and it's mostly accepted for robotic simulations for papers. So if you are going to publish a paper on some kind of swarm robotics or whatever, if you simulate it in VBOTs, it's actually accepted as proof of concept. You don't have to actually do it in real life. The VBOT simulation is just directly accepted, provided you can provide the source files via your GitHub repo. Um, the core components in VBOTs is a simulation world, robot model, physics engine, and controller interface. Now, and every file in VBOTs is a world .wbt. So you will be saving everything as a world. A world will contain objects inside it, and objects will have controllers. So in my world, if I'm going to put now robot, for example, which is available in VBOTs, the now robot is an object. If you click on that object, you will be able to see its controllers. Controllers are programs which can be written either in C or Python for this application. In that, you can do whatever your controller actuation whatever. So this is the general structure of the box, right? You create a new a world, you add objects to the world, you configure controllers for those objects. That's the general flow. Um, and of course, like I mentioned before, the physics engine is genuinely good in robots. It's the standard. Uh, like I said, now a soccer, right? So robots has been extensively used for simulating now a soccer because it just works well for swarm robotics, especially when there's real physics involved, right? The architecture of robots goes like this. So the simulation core is there, which manages the 3D rendering, the physics calculations and stuff, very low level. On top of that, there is controller communication. Communication basically you will have controllers as Python or C files, like I mentioned before. And between them, communication takes place between using either shared memory or transmission control protocol, depending on how you define the code. So I think in Python it's TCP and in C it's shared memory. I'm not sure. Let's look into that. Right. And yeah, it provides custom plugins, etc. For example, now is a great example here because in VBots you will be writing your own programs, right, for controlling. Now is proprietary. How are you going to control it? So VBots has actually developed an API for Now, which you can download as a plugin. I think in the newer versions it comes pre-configured as a plugin, but in the older versions you would have to download the Now plugin and do it. Right? Um, Communication and interface. So it has controller API access where each robot will have its own API, each provider robot that is, and you can just call those functions. A small note here, actually, for Now and Pepper, the proprietary ones, um, the controller in VBots is different from the Python SDK. Like they are not interoperable. The definition of objects, classes, functions, etc. is slightly different in VBots. So it will still work for your simulation algorithm, but you can't directly port it over. But there is a workaround there because it supports ROS and ROS2 integration. So whatever code you write here, you can just package it into ROS containers. Forget it; it will be abstracted for you. So you don't have to worry about the implementation of it. You can just use that abstract interface for granted and run it directly using ROS2 on your real now. Yeah, okay, fine. Although it is out of the scope of the lecture. So ROS manages everything as a container. Any script, any program, any service, any application will run with it within its own, designated container. Just it is Docker. It's not just like Docker. It has Docker installed. It uses Docker and does inter-container communication. Okay, cool. Okay. So the interface I'll just show you. There's an object, for example. I don't know what robot it is. There's some predefined robot that comes as part of the example. Let's say I'm importing this into the world. Now, if I click on this, there will be different programs under it. Out of that, one will be named the controller. I open the controller program and I configure whatever I want. I change the code, I change the parameters. Just like we did in Choreograph, but here it's an actual program which can edit. Okay? Like it is good. So what do you say? It's a world. Cool. Sure. Yeah, take your time. Yeah. So there are two types of cross controllers, standard and custom, obviously. So the standard controller is what comes when you download an object. Let's say there are some common robots, right? Over there you can see the robotic arm that is NerioNet, sorry, Nerio is the company, NerioNet, right? So I can just download net, import it into this world, right? I don't have to sit and do it myself. Now it will come with a standard ROS controller where you can set up communication between ROS containers without having to do too much tinkering. But if you are building your own thing, like let's say ROSBot you guys saw before, right? So if I were to create a digital twin of ROSBot inside VBots, then I will have to write my own ROS controllers. I will have to because everything is custom developed in that. The left motors the left motors share one driver, the right motors share another driver, which is interfaced with the DNC chip, which is interfaced with the nano slash pi. Okay, so this is how the what do you say? It provides support for custom applications as well. Um, so, quick note about ROS, right? So you have to use the VBots ROS or VBots ROS 2 package, currently whichever version you're using, and you will have to download that separately. Okay. You can read their docs for detailed download instructions according to your version, environment, etc. Um, okay, it's a little bit of headache, but it's one setup, right? You first install the driver. You install. I mean, for that you'll have to get a particular version of Python or C++, whichever it asks for. And I think C++, it has backwards compatibility in VBots, so you don't need to worry about that. For Python, you have to download the exact version, Python 2 for ROS and Python 3 for ROS 2, and then for data publishing. One key point I missed out on before is it supports a lot of very, very, very precise and accurate sensors. So if I were to simulate an autonomous driving car, for example, it has to have a sophisticated LiDAR unit, right? Now, this 3D LiDAR unit, you can just simulate it. It has a lot of open source support. You can download specific products, specific LiDAR sensors, just import them into the application and use it. Okay, it gives a very realistic simulation. Um, architecture again. So this, I know it's hard to understand in the first go how everything works together, right? So you have the rewards code, which does like the physics calculations and stuff like that, and then you have the rewards ROS2 driver, which bridges between ROS2 and rewards, right? So that is the communication interface between ROS2 and rewards. Okay. Now ROS2 nodes. Okay, so ROS2, some key concepts are nodes, topics, and services. Nodes are different containers. Topics are something that these nodes, subscribe to. And when a node subscribes to a topic, it can see any message that's being delivered via any protocol to that topic. So that's the general architecture, right? And services work a little bit differently. You'll have to, read up on that later. So this is the general architecture of everything. And yeah, the key point is that this ROS2 driver is required because it creates a bridge between reports and ROS2. Now, benefits of reports and ROS2. So why would you want to use ROS or ROS2? Even, it's a bit of a headache, but you have to use it in some conditions where you want to do very, very realistic simulations where you don't want any gap between what you're simulating and what's happening in real life. So if I have a very specific requirement or very specific application. Let's say I want to simulate something with moon gravity, then I will have to build scripts and environments for that exact application. And that's where ROS2 will come into play because there you're going to have slightly different physics. So that low level thing you need. And there is seamless transfer also. So if you're developing using ROS2, let's say I'm writing some code for Now using ROS2, I can just run it on Now also directly with minimal changes, actually no changes in ideal conditions, right? Like I said, VBots has its own API for Now, which is not interoperable with the real Now. So now if I'm going for ROS2, I can write the code in VBots API, which is easy for me to do. It creates the bridge between ROS2 and VBots. So you don't worry about that. The driver takes care of it. And then you can just deploy ROS2 on now. So that is one primary advantage of working with ROS2 in general, not just VBots. Because you can use that same code directly on the real robot. Right? And ROS2 actually has built-in support for a lot of common robots, which include now Net, Pepper, and quite a lot of them actually. So any standard educational robot or research robot that you want to find, Cross2 probably supports it already. So you don't have to write anything by yourself. Um, obviously, ROS has its own ecosystem, which it has its own tool chain. It has RViz visualization, which you saw with ROSbot. So you can actually see the SLAM mapping in real time. So these are some benefits of working with ROS2 and VBots together. Right. So in the beginning, I said something about swarm robotics, right? So robots mainly we use for swarm robotics because it mimics the real world physics, and also the it's a little bit more lightweight in the sense that I can have some 50, 60 drones doing something together synchronously, and it won't actually have an issue. I was running ROS in one old Intel i5, so and there's no GPU, right? So that's one of the main things, right? And like I said, the same thing in fancy was scalable multi-agent simulation, ROS to native inter-robot connection. Yeah. So here's the main advantage of robots in swarm robotics. That's it. So let me just move on to the real environment of robots. It will take a second to open. Just give me a minute. Yeah, see, it's loading the word, right? Now, this is the default world, just one small, yeah, one arena. It's called an arena in Lisboa, right? So this is the standard world. It's like forum, cross forum. That's the standard thing. Sorry. Yeah, it's similar. So it solves the four queens problem. Yeah. Anyway, so you can create any arena of any size with any objects in it. Now, let's say I want to create a new world. It just has a nice wizard. You don't have to set any one-word commands. It has a good wizard. You can just create a new world. You can select things. Direction, lighting, and the arena. All of which I'm gonna give yes, and I'm gonna give the world a name. Let's say demo world, for example, right? Let's call this. Okay. Now we have a demo world. Like this is the default world that I created, so it looks similar. Now I want to import a robot into this world. I just click on that plus. Here you will have two things called base nodes and proto nodes. Inside base nodes, you will have ordinary things like I have a few examples. Robot, it's just a default robot, and you can't really do anything with it. The same thing, shape, where you have squares, circles, etc. So now, I mean, 3D shapes, cubes, spheres, etc. So these are the base nodes. Proto nodes are like the current, built-in nodes. Just a second. Yeah. So if I open total nodes, these are the built-in nodes that come with robots installation, right? So let's say I want to include a Now robot specifically. So I click on robots. Inside robots, these are all like what do you call companies which manufacture, like Boston Dynamics, etc. I moved down to SoftBank. SoftBank Robotics makes Now and Pepper, of which they support only Now in this. So here, I'm just gonna include Now robot. Right. Then I need a mouse actually. I have one about this. Guys, don't use this touchpad. You'll regret it. Yeah, it needs three axis, and I mean you can use it with touchpad. It's just hard to do. Uh, is it working? Just a second. I'll get my. Okay, here we go. That's a little bit better. Now, uh, okay. So you use these. Yeah, there we go. Now I think it's a better view. So you can zoom out and whatever. I'm sorry about it being slant. There's no space here. Now, so if I open now, I hope it's visible until the end. This panel. Okay. So if I open now, which is an object, like I'm going to remind you, this is the world. Now is an object in that world. The arena is also an object in the world. So if I have this controller, now let me just select a controller. I have written on controller previously. Now, yeah, there we go. Now, if I were to play this, it will just wave high. So it is very high, yeah. Now, this is a very simple controller that is written in Python, right? So, if I were to edit it, you can see the code for the controller. See, start defining your class. It is of type robot, and there is a standard Python code. Like you have to mention in the argument the type of object you will be including. You remember the base nodes, robot, box, random things are there like that, right? So you have to define what kind of base node it is. And you have motion files here. These for example, it's very nice, right? These are defined under motions. So if you open the both project folder, you will see all the folders and files which are containing all of this, right? You're going to use that as modules here in your controller code. So start motion. So that's okay. Click the button. That's all. It's a very simple thing. But click the play button. It started motion. Just let currently play. Stop it. If it's not playing, just play. So it is just play. So it's not a toggle between pause and play. Very simple, right? So now this controller is for rewards. If I were to write a controller that is more sophisticated for some specific application, the trigger for the center start will be a different one, which I'll have to define in another file. That's all. It's very easy to get started, very easy to use. Okay. Now you see these templates, right? Gyro, angular velocity. It's all being printed in real time here. Alright. So yeah, that's about it for rewards. Um, ROS to integration again. If I'm going for ROS, we need another workshop. I'm sorry, like there's a lot of information involved. So yeah, you can. It's online. There are extensive resources online. Like YouTube, you will find so many playlists in GitHub. You will find so many, configured applications and stuff. So there's a huge open source support for it. There's a huge community that supports it. Okay, so that's that. Now, Q&A guys, hold on, I drink water. Q&A guys. Yeah. So you can import a custom object, except you will have to define. See, for this object, the motion files are already defined somewhere. If you're creating a custom object, I'm going to build a robot using a bunch of blocks. Now, for each block, you will have to write your own motion file. Again, that will just be in Python, but you will have to write it. Okay. So custom objects can be built, except you have to write the controllers, you have to write the motion files, you have to define its attributes and everything, right? But then again, uh, any standard robotics application for any project, the general workflow will be people will design things very precisely in AutoCAD, import it as an asset, I mean, express an asset, and then they will import it here, write motions, and then write controllers. See, usual thing. It's possible. It's just that you will have to build the asset file for it. That's the issue. Like you have to actually go to some kind of CAD software, build that exact thing, and then export it as an asset with proper segregation between the parts. And then you'll have to import it and write motion files for each part of the robot. Now, that is a very difficult process to do. That's why Gazebo exists. For custom, you will generally go for Gazebo, but it's still possible here for simpler things. The main thing is with rewards is you want to simulate something in real time. Um, Mostly, have you guys seen those drone shows? Perhaps where in the sky you will see a big screen. Yeah, yeah, right. Now, if you were to simulate that, how many, how much RAM do you think you will need? Hmm. So you get the complexity of it, right? So if I were to just get a nice beefy computer and run a remote simulation, job is done, right? Not a supercomputer. I'm saying like that's why rewards exist. It's very lightweight. Like you might not see gazebo like quality here, but it's great for dynamic real-time simulations which involve physics. I can set the difference in air thinness, for example, down to that granular control I have. Um, any other questions, guys? Um, the controllers are dependent on the motion files, but then, yeah, I mean, the motion files are going to be defined kind of in a markdown for each object. It depends on how you write the code, you know. If you're a good programmer, you will separate your concerns. Hmm. Any questions, guys? Most of you woke up only when now was dancing. After that, you went back to sleep. So, wonderful. For me, this or that. So this will be very useful. I'll just leave it. Thank you, Ashwin.